Welcome, class. In this video, we're going to go over lesson 8.5, solving quadratic equations by graphing. Now, in this worksheet, there won't be that much graphing that actually needs to be done, more so in your book problems. But on these worksheets, it'll be simplified. Now, whenever you're asked to solve a quadratic equation, we're trying to find solutions to the quadratic equation. The solutions are the same thing as the X-intercepts. They're also known as the zeros. If we look at the first example here, we have a quadratic equation that is graphed for us. And here's the actual equation. X squared plus x minus 6 equals 0. If we look at the graph, we see the two x-intercepts. You can already see where the arrows are already marking the points -3 and a +2. What that means is if we plug these values back into the original function, we should get the answer of 0. Because this point right here would be -3, 0. So when we plug in x as -3, we should get the y value of 0, because that's what an x-intercept is. And the other point, of course, is 2, 0. Let's check to see if that's true. If we look up here, x equals -3. We plugged in -3 wherever the x is. -3 squared is 9, plus an x, which is -3, becomes 6. 6 minus 6 does equal 0, so it does check. Similarly, we can plug in x equals 2 where the x is. And here again, we're going to get the same values, 4 plus 2, which is also equal to 6. And of course, 6 minus 6 does equal 0. And 0 equals 0. So that is another true statement. So -3, 0 and 2, 0 are the correct solutions. Now for number 1, it says find the solutions from each graph below. We can already see the zeros here. Now if we didn't know what the zeros were, we could always factor this equation, which I'll still show because it's good practice. So we have one solution of x equals -3. The other solution is x equals 0. Now, if we didn't have a graph, we would actually solve this algebraically. 3x squared plus 9x equal to 0. The first rule of factoring is always look for a GCF. And there is a GCF in this problem. It is 3x. There we go. Sorry, the pen wasn't writing there for a second. We can factor the 3x out. And if we do, we will get x plus 3. Because we're just dividing the 3x out of both terms. 3x times x gives us the 3x squared. 3x times 3 gives us the 9x. Now, using the zero product property, we can set both these parts equal to 0. If we have 3x equal to 0, and we solve for x, we get x equals 0. The other part down here, I'll move it here, is x plus 3 equal to 0. And if I solve, I get x equals -3. And these are the two solutions we got down here. Now, as far as a check goes, it actually wants us to actually check it on the worksheet. So if we plug in x equals -3, we'll do 3 times -3 squared plus 9 times -3. And it should all equal 0. -3 squared is 9. 9 times 3 is 27. 27 minus 27. That does equal 0. Now we have to check the other solution of x equals 0. 3 times 0 squared plus 9 times 0 squared. 9 times 0. And we get 0 equal to 0. So both solutions do check. Now let's look at the next problem. Now, how many solutions are there in this problem? Because it only touches the x-axis once here at 2. So in this problem, there's only one solution, and that is x equals 2. The reason why is this problem could be factored as a perfect square. This is simply factored as x minus 2 times x minus 2 equal to 0. And when you solve, you're just going to get one answer, x equals 2. Because it equaled x equals 2 twice, that means it has a special occurrence. It's called a multiplicity. A multiplicity. And this has a multiplicity of 2 because this answer of x equals 2 occurs here and here. What that means is there's a little bounce on the x-axis. It bounces. And that's why there's only one solution. Now we're supposed to check it. Let's plug in 2 here. 2 squared minus 4 times 2 plus 4. And it should equal 0. 2 squared is 4. 4 times 2 is 8 plus 4. Now 4 minus 8 is negative 4. Negative 4 plus 4 is 0. So 0 does equal 0. It does check. Now let's look at number 3. We see 2 solutions here, one here and one there. Now this problem could be factored again by a GCF. The GCF is minus 2x. Now minus 2x times what value would give us minus 2x squared? And that's simply x. And then minus 2x times what value would give us a plus 6x? That would be a minus 3. Now if we solve both of these parts, we get x equal to 0 and x equal to, excuse me, 3. So we have the 2 solutions here, and we have it off the graph because it was graphed for us. X equals 0 and x equals 3. Let's still check it. Minus 2 times 0 squared plus 6 times 0. If we do the math, we get 0 plus 0. Now let's plug in 3. Here we will get minus 18 plus 18, which equals 0. So both solutions check. Now let's look at the other side of the page. Now it says here to use a graphing calculator. Now we're not using a graphing calculator in this video. Now you will be required to get a TI-84 Plus CE graphing calculator for most of your math classes going forward. Excuse me, TI-84 Plus CE. And this is the most common model you'll see out there. It's this really thin graphing calculator, and it seems to be the favorite for most students in high school and in college. So I'd very much recommend you get this calculator soon if you don't already have one. Now, the example here says a dancer leaps straight into the air, and there's a quadratic function here. As you can see, it has a negative x squared, so the graph looks something like this. And it models a dancer's height above the ground after x seconds. How long is the dancer in the air? Now, this kind of problem tests your basic knowledge of parabolas, and very specifically, a special type of problem. They're called projectile motion problem. Projectile motion. What this says is what goes up must come down. And the time it takes for it to go all the way half this time is exactly how much time it takes for it to fall back down. So if you know if it takes, let's say, 3 seconds to go up, it'll take 3 seconds for the object to come back down. And of course, up here, this is called the vertex. And we can find this vertex using the axis of symmetry formula, x equals negative b over 2a, which is what we used earlier in the chapter. So let's look at the example. Here it's just graphed for us. And they actually found the time. They got these decimals. So I'm guessing when we found the value here, it comes into a fraction. And then the x equals negative b over 2a. And so we just used a graphing. And it said the answer was in the air for about 0.5 seconds right here. According to this, it was 0.5 seconds. Now let's look at number 4. It says using a graphing calculator, which we're not going to be using. If you do have one, you can always type this in, and it's actually good practice. But for this video, we'll just solve these using a simple scientific calculator. So, a rocket is launched from the ground. The quadratic function y equals negative 16x squared plus 56x models the rocket's height in feet above the ground. One thing I want you to always remember is that time is almost always on the x-axis. And of course, in this problem, y is going to be the height. It's going to have a basic parabola shape. Now, we could find how long this rocket's in the air is if we find this time here. And we'll just double it. This time here is along the axis of symmetry. So we will use x equals negative b over 2a. Now we have negative 16x squared plus 56x, and there's a plus 0. There's no value over here. So that's the a, the b, and the c. So we're going to use negative b value, which is the 56, over 2a, 2 times a, which is 2 times negative 16. So we will get negative 56 over negative 32. We can reduce this both by 8, and we'll get 7 over 4. So it takes 7/4 of a second, which is a little less than 2 seconds. It's actually 1 3/4 seconds to reach the maximum height, which means we just need to double it. So if we do 7/4 times 2, put it 2 over 1, we'll get 14 over 4, which reduces to 7 over 2, which is 3.5. Because it's a word problem, it's okay to have decimals in a word problem. So this rocket will spend a total of 3.5 seconds in the air. Now, number 5, a firework is launched from the ground. The quadratic function minus 4.9x squared models it. Again, it's the same idea. Basic projectile motion here. We need to find this value right here. We know that a is negative 0.49 and b is 120. So we can use x equals negative b over 2a. Negative 120 over 2 times negative 4.9. And we'll get minus 120 divided by negative 9.8. Now let's use a calculator here to figure out what that would be. So it says a negative divided by a negative is positive. So we'll just say positive 120 divided by 9.8. So 120 divided by 9.8. And we get 12.24. Doesn't say about rounding, no? So we'll just say the time right here for half of it will be 12 point, I guess we round it to maybe even 25 seconds, which means it's going to take another 12.25 seconds to fall back. So the total time will be those two times added together, which is 24.5 seconds in the air. Number 6. If football is kicked from the ground, the quadratic function y equals minus 16x squared plus 90x models the football's height. After x seconds, about how long is the football in the air? And excuse me, it says the football's height above the ground after x seconds. Again, it's a projectile motion problem, a very basic one. And just so you know, this negative 16 represents gravity. Because there's an equation that we use. It's 1/2 g times time squared, and 1/2 g times t squared. And g represents gravity. And gravity in English units is about 32 feet per second per second. In college, you'll use the number 32.174. And half of 32 is 16. And the reason why it's negative is because gravity is acting in the opposite direction, towards the center of the Earth. This 90 here tells me the initial speed of the football. The football was kicked at 90 feet per second. Let's find how long it takes for it to reach this maximum height first, using x equals negative b over 2a. So it's going to be negative 90 over 2 times a, and a is negative 16. So we get negative 90 over negative 32. Now, negative divided by negative, of course, is a positive. And I want to see, I don't think we can reduce this because 3 does not go into 32. 9, of course, then 9 doesn't either. Oh, they are both even, so we could divide by half. We would get 45 over 16. And that would give us a decimal, but we could leave it as a fraction as well. 16 goes into 45 2 times, which is 32. Let's see, 45 minus 32, you get 13. So it's 2 and 13 16 seconds, which is half the time. So if we double that, we'll get the total time in the air. So we're going to have to add another 2 and 13 16 seconds. When we add these times, we're going to get 4 and 26 over 16, which could be reduced to 4 and 13/8. Of course, 13/8 is an improper fraction. That is just 1 and 5/8. So we'll add the 1 to the 4 to get 5 and 5/8 seconds. So the time would be 5 and 5/8 seconds. But there you have it. We have some application of projectile motion problems. So this concludes the video.